What is a sorting algorithm?
The sorting algorithms organize data into a specific order, such as ascending or descending. They are fundamental in programming and help make searching and analyzing data much faster and easier. There are many sorting algorithms, each with its own properties and use cases. Some sort data quickly, while others maintain certain relationships within the data. Let's explore a key difference: stability.
Understanding stability in sorting.
A stable sorting algorithm ensures that if two items have equal keys, their original order is kept after sorting. In contrast, an unstable sorting algorithm may reorder equal elements. Stability is especially important when sorting complex structures where you want to preserve the sequence of similar elements based on prior sorting passes.
Example of a stable sorting algorithm.
Merge sort is a classic example of a stable sorting algorithm. Imagine sorting a list of employees by age, and within each age, by name. If you use a stable sort for the second pass, employees with the same age keep their name order. Other stable sorting algorithms include bubble sort and insertion sort.
The example of an unstable sorting algorithm.
The quicksort is typically an unstable sorting algorithm. When sorting items with equal keys, their relative positions can change. Other unstable sorts include heap sort and selection sort. In some cases, this doesn't matter. But for multi-step sorting, instability can disrupt data relationships.
When does stability matter?
Stability is crucial when sorting data on multiple keys, such as sorting a list of students by grade, then by name. If the sorting algorithm isn't stable, earlier key orders can get lost. If you're only sorting on one attribute, stability might not matter. Picking the right algorithm depends on your data and needs.